time we start talking about a different mitigation type. This mitigation is the impact of flood duration, right? That's where we stop. Did you guys start doing any coding stuff? Is everything smooth?
Yep.
Reading files. Is there any files missing? Do you need any files that is not there? And I believe I uploaded all the shape files, all the Excel sheets. Everything was there in the drive. If something that is missing that needed to run this code, just let me know. All the input files, I gave it already to you. Okay.
If there's something missing, should the MATLAB give an error?
Yeah, absolutely. But what I mean is, like, while you're reading a file, like shapefile S100, that means 100% of the buildings included.
Okay.
Or shapefile 90, or Excel file, like even the verse 300 lines of code that reads the shapefile uploaded, like in a Word format. You just copy paste in the MATLAB and reads all these Excel files. So I don't want you to write all these reading codes. Okay. All right. So last time, or the last two lecture, we started talking about how we can model the impact of flood barriers, how we can model the impact of water pumping in terms of decreasing flood duration. By the way, all the files that you guys have is just for you. You cannot share with anybody else. Okay, so this is just for the class. I don't know, if you want to build on this research, that's fine, but it's just for you. Okay, just make sure that it's all right. So today we are gonna investigate different mitigation measure. I explained it a little bit over the last few lecture. What is the impact of elevating water-sensitive components? But let me talk first about something else. What do you think about, like, what if we increase the building elevation? Like, let's say buildings on the coastline. We're not gonna do this, but I'm just gonna tell you how easy it is, because some people would think it's very hard to model, but it's not. It doesn't even need any codes. Let's say buildings on the shoreline. Do you guys see the buildings on the shoreline? Sometimes you will find they are one story elevated, like the vertical floor elevation or the vertical story is not starting from the ground. You have to take stairs and then go to the buildings. So it's like one story elevated. They have like piles or posts, like wood posts, and it's like the vertical story, there is no living area. It's just the stairs and you go to the vertical story. That's maybe a huge percentages of the buildings on the shoreline are that way, okay? So if you have a building that is elevated from the ground on the shoreline, and this is kind of mitigation measure, what do you think the best way to model this mitigation in our code? Or what is the difference? How this is gonna be any different from other mitigations that we are doing?
Adding more than the foundation height, which is the height of the first story.
So close. So what is the foundation height is gonna do?
First floor elevation would be
Exactly. So the vertical floor elevation is the only thing that is gonna be different. So basically, it's not it's a mitigation measure, but in terms of modeling, it is not gonna take that much time. Why? Because our algorithm doesn't care about what is what did you do here? Like, let's say that this is our building, and our building is like 12 foot high from the ground, and you have to take, I don't know, like a bunch of stairs like this. So all I care about in this case is the FFE, right? If I have the FFE right, and I have the ground elevation right, and I have the water surface elevation right, so that's it. You don't have to model anything. You just have to input the FFE, you have to model the ground elevation, and you have to model the water surface elevation. So in terms of mitigation, I don't have to do all this stuff. Like, let's say, like if I want to model it, let's say that this is the building before the mitigation. The building was on a crawler space foundation, or something like this, and this is our FFE, and this is our ground elevation, and this is the water surface elevation, right? So that's before the mitigation. After the mitigation becomes like this, that's after. So from my perspective, I will do one change in the shape file. Like my shape file is like this. Have all the buildings data, like building 1, 2, 3, 4, and I have FFE 1 and I have FFE 2. That is before the elevation and after the elevation, right? You increase the elevation. So let's say this one was like 124, then you plus 12 feet. By the way, this is an elevation, not height. So, but let's say not 124 because most of the building on the shoreline, it's like the elevation is 0.
Yeah.
So let's say the first floor elevation is 5. Okay? Then you added 12 is gonna be 17. So when we run the codes based on the new FFE. Rather than taking FFE1, we're gonna take FFE2. That's why I didn't put it here because it's simple. Like you just use the new first floor elevation. We are not adding a barrier, we're not using a bump, or we're not doing that much. It is just you're gonna have a new field with the new first floor elevation. And if I wanna model it for just a few number of buildings or 10% of the building, you select the 10%, you have the new foundation height, let's say it's the 12 foot, and you add 12 foot to the old elevation, so you are gonna have a new first floor elevation, and you rerun the code. So basically, the water surface elevation was like this. So when you protect the building, the water surface elevation is gonna be here. So rather than having maybe 3 foot of water inside your home, the 3 foot of water is below the house. So your house is not gonna get flooded. So basically you have 0 losses.
But they are next to the shoreline, so probability they're gonna get flood much more, I think. Like since they are.
Okay, it's the same probability here and here. Like it's the same house at the same location. They still have the same probability of getting flooded. But the thing is, we didn't play in the hazard. We played in the vulnerability or in the exposure. And that's actually a good topic to talk about. It is like maybe the buildings are like, let's say, are exposed. Okay, like let's say maybe you are exposed to flooding. This building is exposed and this building is exposed. Both are exposed at the same level. Like if here the flood depth is 3 meters, here's the flood depth is the 3 meters. But let's say actually that you have 2 buildings, 2 identical buildings. Okay, this one and this one, but this one on a slab and grade foundation and this one on a pile foundation, right? Or a wall foundation. They are the same building. This one is here and this one is elevated here. They both have the same level of exposure to the hazard, but they both have, not let's say not the exposure, they have the same hazard intensity, okay? They both have the same hazard intensity because they are very close to each other. This is gonna have 3 meter flood depths above the ground, and this have gonna 3 meter flood depths above the ground, or 3 feet, whatever. But their exposure to be vulnerable, or the vulnerability to have damage is different. Because this one is elevated, this one is not elevated. So we played in the vulnerability because when we have the fragility, something like this depth is the depth above the first floor elevation. Okay? So you are gonna have, here's the probability of exceedance, and your fragility is gonna be something like this. This one you have to come at, let's say, 3 foot height, so you'll have to come here. But this one is 0, because the water didn't make it inside. So they are both exposed to the same hazard with the same intensity, but their vulnerability is different, or their exposure is different.
But that's under the assumption they are next to each other, because if they are in different location, the one next to the shoreline is gonna have more reason to fail. Like maybe the soil.
Okay, so you are gonna use the new hazard intensity, and you come here with the new new intensity.
I see.
So what I'm saying is I'm talking about a specific case.
Yeah.
All right. Okay, so maybe you are not let's say maybe you will be exposed to the hazard, or maybe you will have a hazard. There's a probability of the hazard to happen at this location. But what I played here, I played in the exposure of the building.
I see.
So this building is less exposed to this building. And when I mitigate the building, like let's say I'm gonna elevate the water sensitive component. Like let's say here, if I have an AC, I'm gonna put it in the attic. If I have an electronics, I'm gonna elevate them, or I'm gonna do something about this. Here I'm playing in the vulnerability. Same thing with wind. Okay, for wind, when you improve the building, like put, I don't know, hurricane clips on the roof, using different kind of, you play in that vulnerability. So you increase the resistance of the building. So when you play in the building itself and improve it to be better resistance, so we are playing in the fragility itself. But when we are trying to make our buildings less exposure, like using a flood barrier or using or elevating the building, we are playing in the exposure. We're making it less exposed because we didn't do anything to the building inside. Also, I mean, in terms of flood, yes, we didn't do anything to it. We just elevated the building to decrease its exposure. Okay? But if we're hazard, like when we use bump, we are decreasing the hazard. When we use seawall or levees, we are decreasing the hazard. So that actually takes us to the topic that there is a hazard mitigations, there is exposure mitigations, and there is vulnerability mitigation. You can mitigate at different levels. Okay? So when I use a levee, this levee is gonna tam the water and protect you so it decreases the flood depth. Rather than having a flood depth of 5 foot, you're gonna have 2 foot or something. That's a hazard. If you build a retention system and this retention system take from the water that goes to the downstream, so we are decreasing the hazard. Okay? If we are using bumps, we decrease the flood duration. The flood duration is also a hazard, the hazard itself. Okay? So all these hazard mitigation measures. But when we build a flood barrier, that's an exposure mitigation measure. Because the thing is, you try to make your building less exposed by building this mitigation barrier. Okay? But if you did something in your building, let's say that you made your building waterproof, like somehow you built something here, you put a waterproof thing around your house, like let's say you have a wall here and a wall here, and you put something that makes the water less infiltrated inside the building, so you improve the building, that's a vulnerability mitigation measure. Let's say that you elevated water sensitive component, that's a vulnerability mitigation measure. So we played in the fragility itself. When you play, because the fragility is the resistance. Okay, so when you play in the resistance and make it more resistant, so that means that we having a vulnerability mitigation measure. So that's something that you have to put when we do mitigation. So for now, although we have done, we only investigated flood barriers and we investigated water pumps. So I talked briefly about elevating the water sensitive components. So, and the thing is, do you guys, if you saw the files, the Excel files that I gave to you, you will find that for this 3D, okay, you will have an Excel file that says, I don't know, fragility band, and there's one that has EC. EC, that means that's a new fragility if we elevated the water sensitive components. So, from here. All right, so this data is without elevating water sensitive components. If we elevated the water sensitive component, we are gonna use this Excel sheet. Same thing with the 3D fragilities. I have one, it's called archetype F1 3D and one F1 3D elevated. Same thing for archetype 2, 3, 4. So I only have 4 archetypes with elevated components. If you wanna have more information about these archetypes, you can refer to the paper that I published in 2020. You will find more information about these stuff. Do you guys know how can I uncheck, I mean like this checkbox for not to be in the view?
I think from the view back.
Where's the view?
Not this.
check this paper, you will find information about the components that, and that's also, I did it for only the residential buildings because that was the only reasonable mitigation that I believe if it's a commercial building, nobody's gonna think about elevating anything. So it's mostly homeowners, they can do these mitigation measures. Oh, it's not here. It's a different paper. Here. Right, so this is the components that I elevated and I changed the elevation. And that's the old elevation, mu and sigma, and that is the new elevation. And that's the component replacement cost. And these components are like appliances, AC, HVAC, pipes, anything that can be elevated and handy and you can move it, all right? And I included the prices of all of them. So that's the old elevation and that's the new elevation. And I believe I have them, okay, let me show you how this is changing the fragility, because I believe the way that I presented them here, it's only how they are changing the flood losses. Like you will see, let me see here. Yeah. Here I only presented how this is changing the flood losses, and I showed this curve to you before. The red one is with elevated components, so once you, the blue one is the original one. Once you elevate the component, the flood loss curve is gonna go a little bit less. And definitely the fragility, but I didn't show the fragility here, but it's published in another paper. This is the paper name. It's called Modeling the Impact of Building Level Flood Mitigation Measures Made Possible by Early Flood Warning. It's a very long title. And I believe I have, yeah, it's like a figure shows you how the new elevation and the old elevation, and here I have the same table, I believe. Well, it's actually not the same elevation. I believe I changed some of the elevation, but just maybe double check. Yeah, here's the fragility. Shows you how the fragility curve before and after, how it's looked like. So this one, the one, the dashed one, is with elevated, and the other one is unelevated. And this is the loss function, how it's changing. So you can double check both, but these are based on the stuff that we have here in the Excel file. So I have both. I mean, like in the elevated files. So it's based on either you're using elevated or not elevated. Okay, so you already have the input files. Let's see how we can use them. Last time we stopped at at the D1, D2, D3, everyone was for different flood duration. That's the last thing that we have done. The next thing is, this code is not important. I was doing something for the reviewers, so this piece is not of our interest right now. We are gonna start from here. So in this piece, we are gonna see how we are gonna model the impact of elevating components. All right, from your perspective, I already gave you all the input files for the elevated components. What do you think is gonna be different in terms of coding? Like, all right, you already have the Excel file for the elevated fragility, 2D and 3D. 2D is to do the base flood loss analysis. 3D, that has the different durations. You already have all the Excel input files. In terms of coding, how this is gonna change?
I think it will be changed only for the vulnerability or the fragility curve or loss curve, which we will go and interpolate for it.
Exactly. That's the only difference that we have. It's the same thing. Like, let's say we are calculating flood losses. We are going to the original fragility without elevating components. So rather than using this function, I'm gonna use the new function. So rather than using the original fragility, interpolate in a different one. We're not gonna do anything different. I mean, like, not the stuff that we have done for the bombs and the elevating components. We're not gonna do this. It is just rather than when you calculate the losses, it's rather than going in this curve, go in this curve. So that's the only difference. Rather than interpolating in this curve, interpolate from this curve. And we are not gonna do anything different from what we have done before. And we are gonna do this for 10% of the building, 20%, 30%, up to 100% of the building are gonna elevate these components. And also, this is only for the residential buildings, because we are assuming that residential buildings are the only one that applying these mitigation measures. Like schools, hospitals, commercial buildings, they don't have washer, dryer, or maybe they have, but they are not gonna do anything about it, all right? Okay, so, look what I did here. I just prepared the matrix, and this matrix has the losses that comes from if the buildings have, for elevated components. So actually that one is elevating components with pumps. I'm not sure if I have a scenario. Let me check if I have a scenario just with elevating components. Oh, sounds like I didn't develop a scenario by itself that has elevated components. I believe the way that I did it, because elevating the water components by itself wasn't that significant, so I merged it with other scenarios. So I could have, like for me, like the way that I did it here, I could have developed a scenario just with elevating the water sensitive components, but I didn't do this. I merged the two scenarios together. What if I used the water pumps while elevating the water sensitive components? If you guys remember from last time, we did the water pumps like just interpolating at different sections in the fragility curve, right? So rather than I'm gonna go in the 3D fragility, the original one, I'm gonna go in the 3D fragility that has elevated components. So look at this. So here, like if you guys remember from last time, that was the name of the matrix. It was loss, and I put here depth duration 1, S100. Okay, that's what I have from before. So rather than this name, I'm gonna put a new name just to mention or just to describe that this one has elevated components. I'm gonna calculate losses, and this losses, in the case of the building, has elevated component at duration scenario number 1. I believe duration scenario number 1 was when we have 1 day, and then 2 is the 2 days, and then 6, 8, 10. All right? And this is S10, that means I'm gonna do this only for 10% of the buildings. And this is just, I'm just preparing the matrix, and I'm putting zeros just to prepare the matrix that I'm gonna fill it. And then we are calculate, when we have R, do you guys remember when we have R, what does that mean?
reduction.
That we were calculating the reduction in the losses. This, we are calculating how much losses that this building had. The next thing, how much reduction. And the last thing, when we have our total, that means we need one single number for the entire community, how much of flood loss reduction are we gonna have. And I figured out at the end that I'm not gonna use this number. At the end, I wanna know what is the total number of losses. Like I have 137,000. This is the losses without any mitigation. What I'm interested in, how much this losses is gonna be if I apply the mitigation measure. Let's say it becomes $100 million. Since from the curve, I can see the difference, okay? If I want to model, like, you can actually plot a curve like this. Like, I mean 2D curve, and this 2D curve, you can put loss reduction. Oh, let's put the loss reduction here. And here, I'm gonna put the mitigation scenario, the scenario. Let's say scenario number 1, scenario number 2, 3, 4, and 5. The thing is, the more that you increase the mitigation, the more the flood loss reduction is gonna go down. You can put it that way, but the way that I put it, I didn't put not the loss reduction, I put it the total loss. The way that I plotted the figures from last time, if you guys remember. I had this one is not loss reduction. This one is a total loss, $133 million. And this one is not loss reduction, it's the total loss. But the thing is, I can visualize the reduction from here, okay? So I can see how much reduction that I had. If you want to plot the loss reduction, you want to subtract this from this, and this from this, and this from this, and this from this, and you can get values, and these values you can plot them and see how the reduction trend look like. And definitely, here's the reduction is less, it gets bigger, bigger, bigger until you have 100% of the building are applying the mitigation measure. You can plot it whatever you want. I found that that way is much better to visualize the losses. Okay. Let's get back to the MATLAB code. So I here having the total loss reduction, and this is for elevated component case. And I have the same code from last time. For each building in the shapefile that has 10% of the buildings, if the building is archetype 1 and 3, the ones that have a crawl space foundation, interpolate. That's the only difference from the code from last time. If you check the video from last time and this video, you will find the only function that is different is this function. Look at this. I have F, 3D, loss, elevated component. This, just these 2 letters. Let's go to the code from last time. Going to the code from last time, you will find that we are interpolating in a function, it's called F3D loss. So basically, I'm asking MATLAB, rather than going in the 3D loss original curve, go and interpolate in the 3D loss with elevated component, right? So that is the only difference. And actually, you can copy one of the codes from the one that you have done before, like the S10 before, like, okay, let me see how can I do it. Let's say I'm gonna copy this code. Control C, and I'm gonna make a new page. I wanna make this code the S100 to be S10. So first thing I'm gonna change this from S100 to S10. So I'm gonna find and replace any S100 with S10. All right, and change it. And I want to make this with elevated components. So I wanna make this like this one. You see? That one has loss, and there's loss elevated components. So the thing is, I want to change any word that has loss to have loss with elevated component. And the same thing, I want to change it from F3D loss to F3D loss EC. Okay, so let's change this first. I'm gonna take this Control C, and I'm gonna go to the new file that I have done. This one. I wanna change this from F3D loss to F3D loss with elevated components. And I'm gonna find and replace all. So this is my new function. Okay, so I didn't write any new code, it's all from previous code. And then I wanna change this from loss, say Control C, Control find, and I'm gonna change it to AC. And another one, let's say what's gonna happen, replace all. And I replaced all of them. I believe all of them are right. So if you go check back your code, then you copy this and paste it back in the original code. You will find it's the same like this one. All what I'm changing, and I told you before, you have to name all your variables. Look, we are like in the 2,300 lines of coding. So you have to name your variables in a way that makes sense, because we have many variables. So name them in a way that you can understand the validation. Oh, this one has a validated component and had flood duration, and it's for 20% of the buildings. And if there are many variables, you have to put them one by one. If you name them random stuff, you come next day, you will not understand what you did the day before. Okay? All right. So I have done this. Does anybody have any question? It's almost the same code. I'm just changing some names, and I'm changing the function that I'm grabbing the flood fragility from. And if you told me, did we actually input this function? Yeah, I gave it to you in a Word file. Like if you check, I believe the Word file is in the drive. Like I'm gonna go to the drive just to make sure that everything is in there. Okay, so you will go to the project document. And then you will find the raster files, the shape files, and you see here, you'll find all the Excel files, and another one was elevated components. And I believe there's here, this is all the MATLAB lines that you need so that you can read all these Excel files. Here, in this Word file, the one at the end. And if you go back to the MATLAB code, you will find the early adverse that we have been spent like 300 lines to read all these 3D losses. Look, we read this matrix for the 3 flood losses and another matrix, same thing with elevated components. That's for loss function. Going here, I'm reading all the 3D fragilities. I give you all this line. All right, let's get back. At line 20, I believe 600. Yeah, that's where we are. So I have the losses. Let's go back here. So for archetype 1 and 3, calculate the losses. Look right here, elevated components and scenario number 1 of flood duration. It's the flood duration of 1 day, 2 days, 6 days, 8 days, 10 days. And here, interpolate in a new function that are 3D and has elevated components. And in this elevated components, I told you before, it's like a 3D surface. But the thing is, once I put a number here, that means I'm taking a section in this 3D surface and I'm interpolating at this section. But if I put this, that means I'm interpolating in the 3D itself. But once I put D1, that means I'm interpolating just in 2D dimension. Like I'm taking a section in the 3D. And since we are having archetypes on ground space foundation, we are measuring the flood depth from the ground elevation. But if not, the flood depth is going to be measured from the FFE for the other archetypes. And once we calculate the loss percentage, we multiply it by the building value. So here we put the building value, and I told you why we are dividing by 100, because the way that the loss function, it's not 0.99, it's 99%. So we divide by 100 so that we can make it from 99 to 0.99, and then multiply by the building value, which is $1 million. So we're gonna have 990,000 in losses. Okay, so I have this line. Okay, I finished, and once I finish, right now I calculated the losses for each building. Then I did another calculation for the loss reduction, and I told you before, for loss reduction, all what I have done, I subtracted the base flood losses. Look, this is the flood loss that we calculated last time. Without any elevating components. So I'm seeing how much elevating the components is gonna help me. And look at this. Why? Let me get the laser pointer. Why do I have D5 in all of them here? And I'm subtracting D1, D2, D3.
Because D5 is without any mitigation for duration.
For what duration?
D5 is 10 days.
And why I have 10 days in all of them, and I have here, this is 5 days, this is D5, which represent 10 days, this represent 8, 6, 2, 1. If you guys remember, the D5 is the base flood mitigation. Like D5 is the section at the 10 days, which is like if we didn't consider duration. And I told you that the last curve on the 3D surface is almost the same if we didn't consider any mitigation. Like if you go back here, the last curve, this curve, this one represent like at 10 days, it's like you didn't do any pumping, okay? So this one represent the base scenario without any pumping. But here, yeah, here it's like having pumping. Because the thing is, you're not gonna pump the water for 10 days, right? So, or if you did, it's like you didn't, because if the water is gonna stay for 10 days, so it's better not doing it. You know, don't spend time on pumping, all right? So if you have it 10 days, it's like almost very close if like we didn't account for the water, all right? So that's our base scenario. And actually you can use your base scenario as the 2D function. Like you can use the 2D function, the one without any consideration of the flood duration, you can use it as a base. But here I use the one that was at the 10 days. So, going back to the MATLAB code, here, all right, I have here my base scenario without any elevating water sensitive component, and it has the one with elevating water sensitive component and decreasing the flood duration from 10 days to 1 day or 2 days, and then go back and so on until we account for all the flood loss reduction. And if you want to calculate the total flood loss reduction for the entire community in just one number, keep accumulating these numbers one by one in this matrix or in this storage. So once you calculate losses for building 1, put it here. Building 2, put it here. So I'm doing summation for the building total loss in this one. And this represents the losses if you have elevated components, and this means reduction total for flood duration 1 day for 10% of the buildings. Okay? And once I'm done, I'm putting here all the flood loss reduction. I'm writing them outside in this matrix. And then I'm going to the 20%. And I told you, in this case, all you have to change is just one thing. You go back to the folder that you have here, and if this one is right, and it has all the elevated components, you will say Control, let me take this copy, Control C, Control F, and I'm gonna change from S10 to S20, and then replace all. And then you are gonna put back. The thing is, I replaced it with 20 because I already have a shape file that is already defined and it has S20, that means 20% of the buildings. And you do the same thing, so on, until you get to the 100% and paste it back. So you are not writing this code again. You just find, replace, copy, and paste, and it's done. All right. So going back to, does anybody have any questions so far? All right. Once you do this,
About D5, when you subtract it from D1, D2, D3, like do you account for water pump or is it?
that's the water pump.
That's the water pump.
Yeah, the water pumps, that mean D5 is a scenario coming from the water pump that represent bumping the water to decrease the flood duration from D5 to D1. D5 represent 10 days of flood duration, D1 represent 1 day flood duration. So that's a bumping scenario.
But for the elevated, right? For the new one?
For elevated components.
Okay.
Yeah. The one that we did last time, actually the last time we did the same thing, but there was no elevated components.
So we're doing the same mitigation for the elevated?
Yeah, with elevated components.
Okay.
Yeah. All right, so you will do this for 20% of the building, and then 40%, 30%, 40, 50, 60, and then you will copy and paste until you get to the 100% of the buildings. That's the 100% of the building. Then you are done with this mitigation scenario, and we are done with the scenario building using flood barrier, or using pump with elevated components. So 3 mitigation scenarios, or 3 mitigation measures, not scenarios, because each measure has multiple scenarios. Because when we did barrier, we did scenario that the barrier is 20 centimeter, 40 centimeters, 60 centimeter. Bumping, 1 day, 2 days, 5 days. This is the scenarios. But the measure itself is the bump, or the measure itself is the flood barrier. Okay, so going to the next type of mitigation measure, once we are done this, look at this one. I'm gonna use a flood barrier with elevated components. The one that we did is bumps with elevated components. But what if I used a flood barrier with elevating the components? But the thing is, look at this. Yeah, it's almost the same thing. You are gonna do the same thing that you have done to the barriers from before, but rather than interpolating in the original function, you are gonna interpolate in a new function that has AC inside it, okay? Look here at the code. The thing is, I read again the shape files. I don't have to do this. It's extra lines, because I already read the shape files up there. Okay? I read the shape file that has 10% of the building. I extracted the FFE. I extracted the ground elevation. Extracted everything. So let me go up and show you if I read them or not. Like, I'm gonna go to the. So if you look here, I copy paste the same code. I shouldn't have copied that part. All right? That happens why? Because when I redevelop the new code, I copy paste even with reading the file. So you don't have to read this again. It doesn't matter. I mean, like, it's not gonna take, but it's gonna take a little bit of time because we are reading it 10 times for 10%, 20%. But you can exclude this part and just copy this part as is. So what I did, I copied the same code that I used from 2 lectures ago for the flood barrier and took it alone. Here. Yeah. This code. And I define, look, I have here the base loss from fragility base for S10, and I have the loss with elevated components, FR, that means coming from the fragility. Actually, I can't remove FR, in naming, it doesn't matter that much. I already know that all the losses is based on fragility. Like, in terms of naming, I could have get rid of the FR, but this is the way that I wrote it back in the days. So I understand this is for elevated component, and this is for HB1, and I remember HB1 was like 0.2 meter, 20 centimeter, and this is for 10% of the buildings, okay? And I'm preparing the matrix, I'm putting zeros here, and here I'm calculating reduction, flood loss reduction, and here I'm calculating reduction total for HB1 and for 10% of the building. And it is the same code from last time. I'm saying if the building, for buildings that archetypes 1 and 3, calculate the flood losses, the base flood loss. And I use for the base flood loss, you see, I use the F3D loss at D5 because I know that 10 days is considered as the base flood loss without any duration included. And then I'm saying if the building ground elevation is less than H barrier HB1, so the flood losses is 0. The same thing that I have done last time. If the barrier height is here and the water is here, the losses is 0. But once the water exceeds the barrier height, so we are gonna start to have losses. That's what I have done before. So look at this. I have a new definition. Here I have losses and I have AC here, elevated components. Okay? The one that I have from 2 lectures ago, this one, I'm going to take a Control C. Okay, on top here. And I'm going to go back to this one. Let's delete everything and put this Control V. So it's the same barrier that we have. Look what I'm going to change. I'm reading the same files. Basically, you don't need these. Like I told you, you can delete them. So rather than having loss and I have FR right away, I can replace this. I'm going to take a Control C and I'm going to do Control Find. And I'm going to replace this with loss AC underscore, and I'm going to replace them all. See? Changed it every name and made it loss with elevated components. And rather than interpolating in the function that has F3D loss, I'm going to interpolate in the function that has F3D loss with elevated components. So I'm going to take this Control C. Do you guys remember the elevated components was at the end? At the end? Okay, I'm going to say Control C, Control Find. I'm going to do this. I'm going to do E, C. I'm going to replace them all. So they got all replaced. So let's go back and see if this is. Alright, so here I have F3D loss elevated component. But let me tell you something. I did one mistake. Do you know it? When I did the find and replace. The thing is, when I did the find and replaced all the 3D losses, I just want to replace them here, and I don't want to replace them in the base scenario. Right? So I want when I do interpolation in the base scenario without any mitigation here, because here I'm calculating the base scenario without any mitigation. I have here F3D loss without elevating components. But when I did it, the find and replace there is gonna change this to also F3D losses with elevating components, so I have to remove it, okay? Because that's a base scenario, without the elevating component, without flood duration, without barrier height, without anything, the first line. And you have to change it in all the lines that you are doing base scenarios, because I'm doing base scenario here, and I believe I'm doing another base scenario here, else, for other archetypes. So when you interpolate for base scenario, you don't interpolate in a 3D loss curve that has elevated components, okay? Like if you look here, when we did the find and replace, you will find that this one has elevated components, and this is a base scenario. That's why I put base here to remind me that this is the base scenario that without any mitigation, and I'm subtracting from this one. It cannot have elevated components, it cannot have flood duration, it cannot have a flood barrier, because that is the base that I'm calculating from, okay? All right, so so just like change these two, basically I will delete this part. And I will go down to the other function. I'm gonna delete this one. I don't think I have any base. I mean, like this control find base. Okay, I have. Oh, I have multiple of them. So make sure that these ones, the base scenarios, when we calculate the loss reductions, they don't have any easy, like let's see what did I do it over there. Okay, like look at this one, loss fragility base doesn't have elevated components, okay? And this one base doesn't have elevated components. So anyone that has base, remove the elevated component from it. Okay, once you click on one, it's gonna show you all the one that has base scenario. 1, 2, 3. Just delete them one by one, and it's gonna be fine. Or if you wanna avoid this, I mean, rather than seeing loss and changing find and replace loss with loss elevated components, you say find loss FR there's different, okay, I'm gonna take Control Z. Okay, remove the elevated components from this code. Let's see another way to do it. So all what I wanna do, I want, okay, no, actually, there's no way around it. Oh, okay, now I get it. You only have to change this one, because if you change it this one, it's gonna change the base here. You don't have to change, like, this is just the name. We are saying that we are calculating this scenario, base scenario for elevated component. But once you change this one, like, okay, I'm gonna do this here. And I'm gonna remove only this from here and from this one here. Alright, so once you do this and calculate the flood losses for base scenario in this function, and this function is interpolating. Here, interpolating this one, sorry, I actually, when I deleted the other one, I deleted from the wrong part. Let me control C this. Okay, this is the loss scenario, this is the base, right? And this is the F3D losses. And once you calculate this based on losses that doesn't have elevated components, so this one is gonna be right. So when you use it in the calculations here, it's coming from this one that is based on this one. Do you guys get what I mean? Alright, so when you try to calculate this one, we use it in the calculation. This one is based on this value, which coming from this value that is interpolating in a 3D function that doesn't have elevated components. Okay? So you already fixed the function from the inside, so the names are right. Okay? Alright. So basically, you are changing this to the one here in the start of the F loop, and it's else. The else part, you are changing this one too, and that's it. Alright? Okay, so
So the first line, does it treat the elevated component or?
yeah, the first part, like we are saying, we are calculating the base flood losses without any elevation. So, and then we are interpolating in the 3D function that doesn't have elevation of the component.
So the output is not gonna have any elevation in it.
Yeah, for the base, yeah.
So why it's called with elevated?
I mean, I'm just distinguish what I'm doing in
Okay.
this loop from the one before. Because we have done the same analysis before without elevating components.
Okay, I see.
But you know what? Actually, I could have not done this part. Like this part, if you don't want to calculate it, which one? Is that with the elevated components? Yeah. Like you could have used this one right away without any elevation. The thing is, it's like I'm saying A is equal to 10 and B is equal to 10 because we have done this part before. This part is the same like the part that we have done it before. Okay, like if you want to use the same, like if you want to use loss fragility base S10 like this, it's okay. And if you want to calculate it again and say loss elevated component fragility base and name them again, that's also okay.
It's gonna give the same.
It's gonna give you the same number. It's like I'm saying I have done, okay, I did a function, it's called loss is equal to 100. Okay, that's what we did 2 lectures ago. Then I did another analysis and I say I'm gonna name it different name, elevated component, and it's also equal to 100. Okay? If you wanna use that one, it's fine. If you wanna use that one, that's fine. So.
Just want to make sure.
Yeah, the thing is, when I copied this and pasted it, and I did find and replace loss with loss elevated component, it changed this name to a new name. But this is still like, it's the same thing, like it doesn't cause that much, because they both have the same value.
Thank you.
Okay? Alright, so I do the same process, look here. Once I calculated the base, I calculated the flood loss. If the flood barrier is higher than the flood depth measured from the ground elevation, put the losses with elevated component 0. But if not, go interpolate in the function loss elevated components and look at this function that I'm interpolating from. F3D loss elevated components. The one that we did last week, it was the same thing, but we said F3D loss and we stopped. Okay, so basically, yeah, we copy paste and just replace this with the elevated component. And then after I have done this, I calculate the flood loss reduction by subtracting the base. Look here, I have loss FR base S10, and then minus the flood loss with barrier number 1 for elevated components. Okay, and then I'm calculating the reduction total by summing every loss from each building inside the same function. And then I'm trying barrier number 2 here. I have barrier number 2. I'm saying the flood depth measured from the ground elevation is less than 0.4 meter. If the flood depth is less than 0.4 meter, put 0. But if not, else calculate the flood losses from the 3D surface with elevated components. And I keep doing this for barrier number 3, barrier number 4, barrier number 5 that has a height of 1 meter. And once I'm done, I do else and I write the same code. Why I write the same code? Because all what we have done is just for archetype 1 and 3, and we are interpolating at a flood depth measured from the ground elevation. So I'm starting the else, copying the same code and changing the flood depth from FFE to the ground, from the ground elevation to FFE, all right? Because we have archetype 1 and 3 with flood depths measured from the ground elevation. You guys remember? We have our tab 1 and 3 are special, and they have a crawl space foundation, so we need to start the flood depths measured from the ground elevation. So look at the difference between this piece from here, below and up. Up, all the flood depths, it's called FL depths from the ground elevation. But going here, FL depths FFE, measured from, but it's the same code. So basically, what I would do, I would copy this code, this one. I already actually did it, like we already changed it, this copy paste from the other one. But if you want to do it, like I would copy this and I just replace any ground elevation GE with FE, this one. And it's gonna be the same code. Alright? And once we have done this for S10, you are gonna do the same thing with S20, 20% of the building, and then 30% of the building, and then copy and paste, like you will copy the code in a different one, find, replace S10 with S20, and then paste. So until you go to the S100, which means 100% of the building are gonna apply this mitigation measure. And then you are gonna be at here. This means we are calculating the flood losses for elevated components, and this means we are calculating flood loss reduction for very high HB5, which is 1 meter for 100% of the buildings. Okay? All right, does anybody have any questions so far? If you look at all what we have done today, it's what we have done last Tuesday. But all what we have done is just like, rather than having the loss function alone, it's gonna be a loss function underscore AC. That means we are using a separate loss function from the one that we have used before based on elevated components. And that's it, we didn't do anything new, all right? So, I'm gonna stop here right now. Next time right now we have done flood barriers, we have done pumping, we have done pumping with elevated components, and flood barrier with elevated components. We have 2 scenarios left, and let's see how we are gonna do them. But let me talk about this. We are 2 weeks away from the end of the semester. So on the university website, it says that the final exams for this class is April 22nd. So I'm seeing, is that the right day that you guys can have the presentation ready and present your work? We only have 2 lectures. Like Thursday and Tuesday, we are gonna finish all the mitigation part that needs to be presented in the final presentation. So we only have 2 weeks, like not the next Tuesday, the Tuesday after. Dates. So the next Tuesday is the 15th. Our presentation is gonna be on the 22nd. Is that fair enough? That's what we have. I believe it's from 10:45 to 9:45 to 11:45. So we have 2 hours. So I know some of you have presentations at that time, right?
Yeah, but I changed it to 11, I think it's 10:45 to
I mean,
11,
there's a big
11.
slot that we have, so you
Yeah.
can either present at first, present at the
Yeah.
end. Yeah. So we have another 3 lectures, and the last one is gonna be okay, we have lecture on the 10th, 15th, 17th, and then the presentation on the 22nd. So we have 3 lectures, okay? And the next 2, I'm gonna continue the stuff that we have, but you keep progress while we're doing the stuff, right? Well, like every time you go home, you finish, and that's how it works. But you are gonna have like 1 week without any new stuff that you need to present so that you can have a presentation. And I'm gonna give you an extra few days after the presentation day to submit the final project summary, like the paper for the project. Okay, like you can have maybe, because extra, I don't know, 1 week. It depends on the deadline for submitting the grades, okay? That's the updates that I have for you for now. Does anybody have any question? By the way, this is not a lot of lines of coding. It's all copy, paste, find, and replace. We wrote the code, maybe a new 50 lines or a new, I don't know, 100 line, but the same 100 line, you copy, paste, and replace. So don't say, oh, I'm writing 4,000 lines of codes. No, it's not 4,000 lines of code. It's all copy, paste, replace, find, replace, okay? All right, if you're stuck with something, just send me an email and we can set a Zoom call and I can check or trace your code with you, okay? All right, okay, sounds good. See you guys next time.